Again, welcome to DSRT 734 class, that is Inferential Statistics in Decision Making. In these lectures, we're going to cover normal distribution, finding probabilities. So our main objective is finding probabilities for a normally distributed variables. So if a random variable X is normally distributed, we can find the probability that X will fall in a given interval by calculating the area under the normal curve for that interval. So what we mean is that, for example, we have a variable X that is normally distributed. And they gave us the mean to be 500. And we have, the 600. So our goal here is that we want to find the probability that the X will be 600. Also, standard deviation is given. So if we have a question and we want to find the probability that X is less than 600, we know the mean of the distributed data, and also we know the standard deviation. So the first thing we're going to do is to find the z-score. So then when we get the z-score, we go to the standard normal table or the z-score table to find the probability. And the probability will be the area under the curve here. So we have 600 to the left because we are looking for probability that X is less than 600. So from 600 to the left. Now, if it's greater than 600, then from 600 to the right. So again, this is our normally distributed data set with a mean of 500, standard deviation of 100. Our goal now is to find the probability that the random variable X is less than 600. So as we said earlier, the first thing we need to do is to find the z-score. So the z-score, what z-score is going to do is to transform the normal distribution to standard normal distribution. So z-score is X minus mu over the standard deviation. S is our random variable value, which in this case is 600. So we have 600 minus 500. 500 is our mean value divided by the standard deviation, which is 100. So 600 minus 500 will give us 100. 100 divided by 100 will give us 1. Now, when we get the value 1, the z value 1, we go to the standard normal table or the z-score table. Then we are going to find the probability based on the z-score. So this is how we transform our normally distributed. So right now we have the mean to be 0, standard normal distribution. Then our value is 1 because the z-score is 1. So now we have to again look for the probability value using the standard normal table, or we using the z-score table. And we're going to do this example in a few lecture slides to come. Our goal here is to understand the concept of, again, transforming the normal distribution to standard normal distribution. And the main goal is to find a z value. A standard normal distribution, the mean or the z value is 0. So let's try this example. Here we say a survey indicates that people use their computers an average of 2.4 years before upgrading to a new machine. So again, based on a survey taken, the data set given to us, we found that average person spent 2.4 years using a computer before upgrading it to a new machine. Now, the standard deviation of this data set given to us was 0.5 year. So a computer owner is selected at random. So we select one computer owner at random. Find the probability that he or she will use it for fewer than 2 years before upgrading. Here we are assuming that the variable X is normally distributed. So our data set is normally distributed. So by looking at this question, we have the average value, 2.4 years. we have the standard deviation 0.5, and our goal is to find the probability that the random variable, which is the number of years, should be less than 2 years. So with these three values given, we can find a z value, which will be again 2 minus 2.4 divided by 0.5, which is the random variable x value minus the mean divided by the standard deviation. Okay, that's the formula for the z. So here again, the question gave us the mean to be 2.4, the standard deviation 0.5, and our goal is to find less than 2 years. So probability that x is less than 2 years. So first thing again, we find a z-score, which will be x minus mu over standard deviation. So it will be 2 minus 2.4 divided by 0.5. And that gives us negative 0.8. So if we know this value negative 0.80, we can go to, again, the standard normal table to locate the P, the probability value. Now in the table, the probability value we get is always from left to the value. If it's less than, if it's greater than, then it means from the value to the right side, which means the value we get from the table, we are going to subtract it from 1 since the whole graph area is 1. And that will give us from the value to the right. So here we find out, we look at the table, negative 0.80, we find out that the probability is 0.2119. And we're going to see an example soon how to use the table. And actually the previous slides also, which is the Unit 5, Lecture 1, we did examples on how to, again, to use the z-table or standard normal table. So another example given is here, we are going to find the probability for the normal distribution. And the example given here is we have a survey that indicates that for each trip to the supermarket, a shopper spent an average of 45 minutes with a standard deviation of 12 minutes in the store. Now, the length of time spent in the store is normally distributed and is represented by variable x. Now, if a shopper enters the store, find the probability that the shopper will be in the store for between 24 and 54 minutes. Now, since this data set is normally distributed, we will find the z-score for 24, then the z-score for 54. Then we find the probability of both of them using the z-table or the standard normal table. Then after that, we find the difference of the two values because it will be in the middle. Again, we will follow the steps here. So this is what I mean. We can see 54 is here, 45 is here. When you are using the table, it always gives you from the left to the value. So if I get from left to 24, and I have from left to 54, then the difference of the area 54 minus the difference of the area and minus 24. So we get the probability of 54 minus the probability of 24. And that will give me the shaded area, 54 minus 24. Again, I'm not using the value. This is just the value given to us. First, we find a z value based on 24 and also based on 54. Then we find a p-value based on 24 and based on 54. Then we find the difference of the two, which will be the z-value that gave us the p-value minus the z-value of 24 that gave us the p-value. So we find the difference of the two p-values based on the z-value or based on the s-value of 54 and 24. Now let's see the steps here. So we can see the first we say z1. So we are assuming z1 is that we are using x for 24. So 24 minus 44 over 12. And that gives us negative 1.75. Then we find a z2. So z2 will be 54 minus 45 over 12 standard deviation. And that gives us 0.75. So when we plot this again, we will see that, again, this is a standard normal form now. The mean is 0. To the right will be positive value. To the left will be negative value. And here, since I have negative 1.75, we plug it. Then 0.75, we plug it. Now, these are the z values. So we find the z value for negative 1.75. And whatever we get in the table, that is the final answer, because from left to the negative 1.75. The same thing from the left to positive 0.075. Then our next step is to find the difference of the p when the z is negative 1.75 and 0.75. And that will give us our solution. That is the probability of the value between 24 and 54 is the solution. So here we can see now, we look at the p-value from the table. It's 0.77534. That's for the 0.75. Then we look for the second p-value, which is negative 1.75. And that gives us 0.0401. So now we find a difference. So we're looking for the shaded area here. So we find a difference of 0.7734 minus 0.0401. And that will give us the probability that our value fall between 24 and 54. So that's what we say. Probability of 24 to 54 will be negative 1.75 and positive 0.75, which we have 0.7734 minus 0.0401. And this will be our solution. So there are three ways of finding probability. The first example we saw, if the probability of the value we are looking for is less, and if it's greater, it will be on the right side. So which means when we look at our table, the value that we get, we subtract that value from, because the table is from left to the value. So we subtract that value from 1, and that will give us from the value to the end. So let's try this. Again, find the probability that the shopper will be in the store more than 39 minutes. So previously they gave us between the interval, let's say between 24 to 54 minutes. Now, 24 and 54 minutes, we find a z-score for 24, we find a z-score for 54. Then the z-value, we go to the standard normal table. Then we find the p, the 2 p-value that is corresponding to the z, the 2 z-values. Then from there, we find the difference of the two to get a shaded area in the middle. Now here we say it's great, and also we saw the example for less than. Less than, we don't subtract, we leave the answer direct from the book, because the book gave us answer from left beginning to the value. Now next, we are doing greater than. So we follow the same step again. We have the mean given to us, and what is the probability that the shopper will be in the store more than 39 minutes. The mean is 45 minutes, the standard deviation is 12. So the same thing, we should be able to find the z. But this is how our shaded thing will be. So we say greater than, not 39. So from 39 to the right. Then we know the mean is given to us. Previously we saw it 45. The standard deviation is 12. So we can find the z. So the z is x minus mu over standard deviation, which will be 39 minus 45, the mean, divided by 12, which is the standard deviation. The answer again is negative 0.5. So if it's negative 0.5, our next step is to go to the standard normal table to find the p. Now, when we look at the p value from the table, we get 0.3085. Again, since it's to the greater section, the value we get from the table is from left to the value. But we're looking from the value to right. So we have to subtract the answer we have from 1, because we know the total area under the curve is 100%, which is 1. So if I want to, again, look for some part to the right, always the answer I get, I will subtract it from 1 to give us the remaining. So our p-value here was, in the table, was 0.38085, but that starts from the left to the value. We are looking from the value to the end of the right side. So we subtract 0.3085, which is the previous p-value, from left to the value. We subtract it from 1, and that will give us 0.6915. Now, if 200 shoppers enter the store, how many shoppers will you expect to be in the store more than 39 minutes? So that's what we want to. We know the mean, we know the standard deviation. So we subtract the mean and the standard deviation. We subtract the mean and the value. In this case, the value is 39, the difference of the two, divided by standard deviation. And that will give us, again, the z value. If we recall, this is what we get. Now, the question was that if 200 shoppers enter the store, how many shoppers will you expect to be in the store more than 39 minutes? So what is the probability that S is greater than 39 minutes? That was 0.6915. In the previous, the same question we have, we were able to find greater than, so 0.6915. So we plug in the values. In this, the formula here is Z equal to S minus mu over standard deviation. So if I'm looking for X, it means I have to do cross multiply, and then we convert the value. So this gives us 200 times 0.6915 equal to 138.3. Now the next example, assuming that the cholesterol levels of men in the United States are normally distributed with a mean of 215 milligrams per deciliter, and also a standard deviation of 25. And also we have the standard 215 for the mean and 25 for the standard deviation. Now the question is, what is the probability that his cholesterol level will be less than 175? And here they say we should use technology 2 to find the probability. So here with the normal distribution, we can use SL have a function as a normal probability. And so many SPSS also the same thing, R also the same. So here, for example, we are using Minitab. So remember the question again said, what is the probability that his cholesterol level is less than 175? So we have 175. So here, cumulative distribution function, which is normal with mean, we have 215,000 and standard deviation of 25, which is, 215, because these two values are given. The mean is 215, and the standard deviation is 25. So that's why we have 215,000, and the standard deviation is 25,000. Sorry, 25. So from here, we can again use the Minitab to find the probability. Now using SL also, we can use the norm distribution. We have our mean, we have our standard deviation, and also the S value. And we asked again to find it. The SL will give us 0.0547992. And it's the same question in the Minitab, which gives us 0.0548. So this will be the conclusion of normal distribution, how to find the probability. So the steps are very straightforward. The first thing is that always in the question, they will give us the standard deviation of the distribution and also the mean of the distribution. And they will tell us that it's a normal distribution, the data set. So to find the probability of a specific value, the first thing we have to do is to find a z-score. Z-score is the value minus the mean of a standard deviation. So when I get a z-score, I'll go to the standard normal table or the z-score table. Then I'm going to locate the p based on the c value given to us. So the p values are normally the values inside the table. And the outside to the left and the header is the z value. So again, we're going to end here and wish everybody the best. Thank you.